So hello, this is Team Brocode with the space, and we are working on a project to decentralize the inventory management for all kinds of hospital, like decentralization of doctors, the decentralization of blood banks, and the efficient placement of ambulance in a city. So what we are having here is the homepage of the website we have built, and now I'll move forward to login. I'll log in as an admin. We have four kind of login access in this system. That is admin, user, doctor, and the ambulance. Okay, so this is our home page, or basically we can say it's the statistic data page. It shows us the regression curve model that is basically used to train the AI model that was generated from the sample data that we used to train the model. And depending upon this regression curve, the data is predicted in this AI model, and this is all the briefing about that. So now I'll move on forward to predict blood requirements. What this does is that it predicts the blood requirement in an area, to be specific, in a hospital, by blood group, by the number of patients, by the number of people residing in that area, by the spread of any kind of disease that is going on, or previous patient data that we have in our database. So this is the data, this is all in units. Now I'll move forward to blood inventory. Blood inventory is basically a very simple depiction of how much blood we are having. That is from maximum capacity we are having 82%, 300 units. It's just a depiction. Now we will move forward to predict donors. So predict donors is a very vast feature. What it does is it records the previous data of all the blood donors that we have. It shows that their name, their blood group, age, and everything, and it predicts that a person will donate blood or not, depending upon these characters like age, gender, last donation date, and number of times donated. So depending upon these factors, the AI predicts whether a person will donate or not. This data that we see here is generated by AI. And now I'll just put a filter like B positive, so it shows me that these are the B positive donors that we have available in the database, and this is the probable donation. So now I'll move forward to blood logistics. What is blood logistics? So blood logistics is basically that suppose in a urban area we have a surplus supply of O positive blood group, but in an area like Sonipat near Delhi we have little to very less supply, and we have a shortage. So what it does that if we keep the blood in Delhi, it would be just go in waste, because we have a lifetime of 30 days and max to max 60 days if kept in a cold storage. So what it does, it supplies the blood from Delhi to Sonipat to maintain a balanced inventory all over, so that in case of emergency we are always prepared. Now let goes for doctor allocation. Doctor allocation is a simple feature that works inside a city. It is also an AI based model. What it does that it divides the city into several areas and the hospitals. It has the data of how many patients are in a specific hospital. It has the area that how many people are residing in the area, and depending upon these factors, it assigns the duty of doctors. So like this Manipal hospital has number of doctors 4 and number of patients assigned are 100. That might be an problem, because we might have less doctors, but it decentralized all the doctor and assigned 4 doctors for the day to this specific location. It's not necessary that they would be assigned the very same location next time, but it could be anything. It all predicted by AI every day. Now we move forward to the last feature, that's ambulance placement. What we have done, we have taken the data of the accidents and the severe diseased patients that we have in the city, and we have placed ambulance at such strategic positions that it takes minimum time to reach to the spot of accident or to help out any injured person. So this is also predicted by AI, and these are all the ambulances that we have in the city, and these are placed at those several points. Now I'll move forward to the training data. Training data is nothing but the sample data that we have used to train, and that's the Jupyter notebook for that blood supply bank. Now let's move forward to the star training. Star training will just rebuild all the code and build new files and new regression models basically. So that's all that I want to tell. Thank you very much.